This is going to be my first tutorial based on a suggestion one of you made. The question was how to do a mining laser like I showed in this demo. And it's a brilliant suggestion. There are a couple of interesting techniques in this I am sure you'll find very useful. There's animation, sound, collision detection, a simple shader and some code to talk about. Now this is more complex than my previous tutorials, but don't worry, we'll go step by step so you can follow along. I did my best to recreate the relevant parts in the simplest possible setting. There's a ship firing a laser, heating up an asteroid until it finally explodes. We will create a simple functional setup first and get to the nifty animation stuff later. So make sure you stay with me. Okay, let's blow up that asteroid. Create a new project. This time we're going to set up for clean pixel art. Now let's set up the main scene. Create a root node of type node. Open the project settings and set the base resolution to 320 by 160. We're using exclusive full screen mode, viewport stretching and integer scaling. This ensures our low resolution viewport scales to whole screen pixels. Add a color rect for the background, give it a nice dark blue color and set the anchors to full rect. Save the scene as main. Let's create a folder for this and the other scenes, and also for the assets we're going to add. One for audio and one for sprites. I have prepared a few assets for you, which you can download from my itch.io page. There will be a link in the description. Of course, feel free to use your own assets instead. Drag the audio files for the laser and the explosion into the folder view. We also need sprites for the spaceship and the asteroid. Sort everything into their respective folders. The first element we're going to add to the scene is the player ship. Create a new scene and call it player. The root node is a node 2D this time. Add a sprite 2D child node for the ship. Load the spaceship texture into that sprite. Now scale the sprite up by a factor of 2. Switch to the main scene and drag the player scene into it. Position the spaceship somewhere to the left. Now press F5 to run this. Choose Select Current as the startup scene. Now why is this all blurry? Because yours truly forgot to change the texture filter mode. Let's fix that. Open the project settings and under Rendering Textures set Default Filter to Nearest. Okay, this is more like it. In addition to the ship, we obviously need a target that we can blow up. Create another scene named Asteroid. The root node should be an area 2D this time because we'll add a collision shape to it later. The root node shows a yellow warning triangle until we actually add that collision shape. Just ignore that for now. Again, add a sprite 2D node. Let's simply call it sprite. The texture I provided is actually a sprite sheet containing multiple asteroid shapes. We need to select one of those using an atlas texture. Select New Atlas Texture from the dropdown. Under Atlas, load the asteroid sprite sheet. Now click Edit Region and in the editor that opens up, select Auto Slice from the dropdown. This creates rectangles framing each of the asteroids in the sprite sheet. Simply select any one you like by clicking on it. Just as we did for the player ship, drag the asteroid scene into the main scene tree. And position it some distance to the right of the ship. Now what is missing? The laser. Once more, create a new scene named Laser with a node 2D root node. Add a line 2D child node, let's call it Beam. Expand the points array and add 2 entries. Leave the first point alone and set the x coordinate of the second point. The actual value isn't even that important here, we are going to set this from code in a minute. Just make it large enough so you can see something in the preview. The default color of the line is white, which is fine. But we want to change the line width to just 1 pixel. Now we need to add this laser to the ship. Switch to the player scene and drag the laser scene into the tree. To position the laser node, center the ship in the preview by pressing F and zoom in a few times. Now move the laser beam to a point in front of the ship. 30 should be a good value for the X position. Let's run this again to make sure all the elements are in place. Here's what your screen should look like now. Alright, now let's put those things together to blast that asteroid. I'm concentrating on the essential functionality for now, we will add some juice to this later. Let's start with the laser beam. Attach a script to the laser scene. I want the beam length to be adjustable, so I have an export variable for that. We need a reference to the beam node. Select the beam node and Ctrl-drag this into the editor to create the variable. I'm keeping the active state of the laser in a separate variable. This is the same as visibility for now, but that is going to change later. The beam is initially inactive and invisible, and we also initialize the beam length by modifying the endpoint of the line. To control the laser, we provide 2 functions to activate and deactivate it. Most importantly, we switch visibility on and off here. Now let's add a sound effect. Create an audio stream player node, rename it to something shorter and load the mining laser sound as the audio stream. As before, Ctrl-drag the node into the editor to create a reference variable. Now call play in the activate function and call stop in deactivate. That's all we need to do here for now. To fire the laser by pressing a key, we need to configure an input action. Go to Project Settings and select the Input Map tab. Add a new action called Fire. We can now map keyboard, controller or mouse inputs to this action. I'll just configure a key press here. Press the plus button and simply press the spacebar while the listening for input field is focused. I want the input handling to be controlled by our player scene, so that's where we are adding the code to check for the input action. Switch to the player scene and attach a new script. In process, we simply use isActionPressed and call activate or deactivate. As the name implies, isActionPressed returns true as long as the key is held. And that is the whole script. Let's have a look at what we have now. If we run this, pressing the spacebar shows the laser beam and plays a sound. Nice! Of course, that laser is not hitting anything yet. To achieve that, we are now going to set up collision detection. In the asteroid scene, add a collision shape 2D. This finally makes the warning triangle next to the root node disappear too. Click on the shape field in the inspector and choose New Circle Shape 2D. The circle shape has a radius field. Adjust that to cover the asteroid in the preview. Oh, and maybe rename the node to something more handy if we need a code reference later. The asteroid is now detectable in a collision. The next step is to look for such a collision along the laser beam. We are going to use a raycast for that, which checks for collisions anywhere on a defined line segment. Switch over to the laser scene and add a raycast 2D node. Rename it to raycast or whatever suits you. You can see in the preview that the ray is initially pointing down. To make it extend to the right, change the target position. The value for X isn't really important here, we will be adjusting that in code in a second. Just make sure the Y coordinate is set to 0. Now we are going to put that raycast to use in the laser script. Ctrl drag the raycast node into the editor to create a variable for it. In the ready function, we initially disabled the raycast. We only need Godot to check for collisions while the laser is active. We also configure the ray length to match the maximum laser beam range. Godot updates collision information in its physics update step, so it's a good idea to query that information in the physics process function. So what do we have to do here? If the laser is active and the ray is colliding with something, our asteroid, we get the point of collision from the raycast. This will be in world coordinates. We now want to calculate the length of the laser beam up to that collision point. With the toLocal function, we can convert the point from world coordinates to local coordinates of the laser scene. Since our laser beam starts at local 0, 0, the x-coordinate of these local coordinates is just the same as the length of the beam up to that point. If we enable and disable the raycast now together with the laser beam, we should be all set. The asteroid is positioned a bit far from the ship currently, so I'll move it in somewhat and also make the laser beam longer. Now let's see what happens when we run this. Well, it basically seems to work, but Houston, we have a problem. On the first hit, the laser is cutting right through the asteroid. Why is that? Remember when I said collisions are updated in the physics step? So we are updating the laser beam in physics process. Now when we activate the laser, that calculation doesn't happen until the next physics update. Is there a way to do it immediately before showing the laser? Yes, there is. First, let's move the raycast code into its own function, so we can call it from multiple places. Then in Activate, we can enforce an immediate raycast update and use the result to update the laser, in case we hit something. Okay, let's try again. Wonderful. We can hit the asteroid now, but it's a bit pointless if the thing doesn't explode. Let's put that in, the final step to make this little demo functional. Go to the asteroid scene. Add an animated sprite 2D node and rename it to Explosion. In the animation section in the inspector, select New Sprite Frames. In the Sprite Frames panel that now appears at the bottom, click on the grid icon that says Add Frames from Spritesheet. Navigate to the explosion PNG file we imported earlier and select it. A new window pops up where you can configure the sprite frames. Enter 3 for horizontal and 2 for vertical divisions to match the 6 explosion sprite frames we have. At the top of the window, click on Select All and confirm with the button at the bottom. Usually, when playing such a sprite frame animation, the last frame is held. We want the explosion to disappear though, so select the last frame, then click on the right one of the 2 plus buttons at the top. This adds an empty frame at the end of the sequence. Alright, we're ready to play the animation. Attach a new script to the asteroid scene. Ctrl drag the explosion node into that script. In the ready function, we initially hide the explosion. You could as well uncheck the eye icon in the scene tree, but I prefer to make these things explicit in code. Now add a new function named explode, which we are going to call when the asteroid has been hit. We simply hide the asteroid sprite, show and play the explosion animation here. An explosion without sound is a little boring, so now add an audio stream player node. Rename it to audio or whatever. Ctrl drag the node into the script view. Now we can simply call play on it. Oh, and we need to set the stream, of course. Quick load the explosion audio file into it. When the asteroid has exploded, I want it to disappear from the scene. Since the audio plays a bit longer than the explosion animation lasts, I connect a handler to the finished signal of the audio player and free the node here. In case the function is called multiple times by accident, I don't want to trigger the explosion again when it is already running. What's left is triggering the explosion. We'll do that from the laser script when a hit has been detected. In physics process, we check if the raycast has registered a collision. If so, we get the colliding object. We know this is the asteroid in our case, since there's nothing else in the scene. But imagine you had destructible and non-destructible elements. A useful pattern here is to check if the colliding element has a method specific to the destructible elements. Here, the explode method. If it does, well, we call it. Now that the asteroid can be destroyed, we also need to restore the laser beam length when the asteroid has disappeared. And that's it. Finally, we can destroy that nasty asteroid threatening civilization as we know it. If you made it this far, pat yourself on the back for saving Earth with your Godot skills. Let's now make the scene a bit more interesting to look at. First of all, we're going to pimp that laser beam. Switch to the laser scene and zoom in so we can see the beam better. Add an animation player to the laser scene. Rename it to Animation. Hide the raycast so it doesn't obstruct the preview of the laser beam. In the animation panel, click the Animation button and select New Animation. Name it Start Beam. We are going to animate the transparency of the beam to fade it in with a flickering effect. The animation is 1 second long by default, which is fine. Add a new property track. Select the beam node from the pop-up. The color of the line sits in the default color property, so select that from the list. You can now insert keyframes by right-clicking on the track. Keyframes can be moved by dragging with the mouse. To modify the color value, edit the value field in the keyframe inspector on the right. We are only going to modify the alpha value here. We want it to start with 0, making the beam fully transparent. At the end, we set alpha to 1 for opaque white. Working in the animation editor is a little finicky. As you see, a newly inserted keyframe isn't always automatically selected, so I accidentally edited the wrong one here. Watch out for that. Now it's simply a matter of adding more keyframes with varying opacity and playing the animation repeatedly until it looks okay in the preview. When you are happy with your version of the animation, create another one called Stop Beam. This one is going to be very simple. We animate the beam color from white to transparent over 0.3 seconds. And don't forget to adjust the total length of the animation too. All we need to do now is run these animations at the appropriate time. Switch to the laser script and play the Start Beam animation in Activate. Of course, we also need a reference variable for the animation player. Similarly, we play the Stop Beam animation in Deactivate. But there's a catch. We cannot hide the laser until the fade out animation is done. One way to solve this is to connect a handler to the animation finished signal. In the handler function, we can check if the stop beam animation was finished and then hide the laser. And this is what we have now. That is already much better, but not good enough. Let's add a nice glow. In the laser scene, duplicate the beam node with Ctrl D. Call the new node Glow. Change the color to a bright cyan. Move it up the tree so it gets rendered behind the beam node. You can see it better when you make the glow line wider. Set the begin and end caps to round so the glow surrounds the center beam. In the script, the length of the glow line needs to be modified along with the existing beam. Finally, set the width of the glow to 4 pixels and the central beam to 2. And that's what it looks like now. What's left is adding animations to the glow. This is very similar to the color animation we did before. Add a new property track to the start beam animation. This time choose the glow node. Again, we animate the default color property. We want a very similar animation to the existing one. So copy the keyframes by drag selecting all of them and choose copy keys from the context menu. With the new animation track selected, right-click again for the context menu and paste the keys. I think this feature is new in Godot 4.3. It's really great to see improvements like that in the animation editor. We can now edit the colors to our liking. I want the color temperature of the glow change from a warm red in the beginning to the final cyan. You can of course do whatever you want here. Finally, I want the glow to grow in size over the course of the animation. I'll do this by adding a new property track for the width property of the glow node. Insert one keyframe at time 0 and set the value to 0. Add another keyframe at time 1 and set the value to 4. We now see the glow line smoothly becoming wider in the preview, but keep in mind that it is not going to look quite like that in our pixelated runtime view. The last step is fading out the glow in the stop beam animation. I'm sure you can do this in your sleep by now. Add a new property track for the default color property of the glow node. Add 2 keyframes to animate the alpha value down to 0, and that's that. Here's our new and improved laser. As a final improvement, I don't want the asteroid to just blow up immediately. It's a mining laser after all, so the asteroid should slowly heat up until it explodes in a loud, satisfying bang. Visually, we can show the increasing heat by making the asteroid brighter until it becomes completely white. This is easily done using a shader material. In the asteroid scene, let's hide the explosion and collision from the preview so we can see more clearly. Select the sprite node and go to the material section in the inspector. Create a new shader material there. Open the material details and create a new shader. This creates a new shader code file. I'll call it sprite brighten. To keep things organized, create a new folder named shaders and move the file there. Now open the shader editor and select the file. We're going to fill out that empty template. The brightness of the sprite is controlled by a single float parameter ranging from 0 to 1. Such a parameter is called a uniform in shader lingo. We'll name it brightness. In the fragment section of the shader, we are first getting the original color from the sprite texture. We're then simply adding our brightness value onto the RG and B channels of that color. So a brightness of 0 results in the original color, moving ever closer to white as we approach a value of 1. Finally, we return this as the output color of the fragment shader. If you've never written a shader before, all of this is probably looking very alien to you. A thorough introduction to shaders can fill whole books though, so I hope you'll understand I'm not going into the details here. As you see, it doesn't take much to get started anyway. Our new brightness parameter has now appeared in the material section of the sprite. Try changing the value. You'll see how the sprite color changes in the preview. Reset it to 0 and enter the asteroid script view. We are now going to add some logic to let the asteroid heat up, cool down, and finally explode when it has accumulated enough heat. We'll need a few variables. One for the maximum heat the asteroid can take. This relates to how long it takes the laser to destroy it. Another variable controls how quickly the asteroid cools down again when the laser stops. I'm using exports for both of these, so the values can be configured in the node inspector. We need one more internal variable storing the current accumulated amount of heat. The general idea is to not just call explode any longer when the laser hits. Instead, we add heat to the asteroid until the critical amount is exceeded. So let's create a new function addHeat, taking the incremental heat quantum that is going to be added. We're only adding heat while the asteroid sprite is visible, that is, it is not already exploding. The new amount is simply added to the current heat value. The max expression here is useful to avoid the value going below 0 when we add a negative amount, that is, when we're cooling down. We can now set our shader brightness parameter to the fraction of maximum heat we are currently at. So, when the heat has reached max heat, the asteroid becomes completely white. Beyond that value, we trigger the explosion. I am renaming the explode function here with a leading underscore to make clear this is now a private function, not meant to be called from another class. This is pure convention, but a good idea to follow. To let the asteroid cool down while we're not roasting it with our laser, we subtract a small heat value each frame in process. All that is left to do is call the addHeat function from the laser script. Replace explode with addHeat and don't forget to pass in a heat value. We'll simply use delta here. This equates to adding a heat amount of 1 per second. And drumroll, here's our final result. If you followed along all the way to here, congratulations, we've touched a lot of areas vital to game programming. And as said, this is my most complex tutorial so far, so please let me know how well you got along. Also, with what we have developed here, it's not too far-fetched to turn all of this into a complete minigame. You know, with the start screen, score, game over, and so on. If you'd be interested in that, drop me a comment. Hope you had fun so far and learned something new. Until next time, keep making games. Bye.